Well, we have another question here, question 9. The question says that a reticular cone with radius p and height t is machined cut out from a solid sphere with center C with a radius of 30 centimeters as shown in the sketch. Now, question 9 says from question 9 here, it is say that from the given information, well, we have another question here, question 9. The question says that a right circular cone with radius p and height t is machined, cut out from a solid sphere with center C with a radius of 30 centimeters, as shown in the sketch. Now, question 9.1 says, from the given information, express the following. So 9.1.1, AC in terms of T, right? We can see that AC is this length here, okay? But now, and then T is the whole this, okay? Now, we do know that the radius is just 30 centimeters. So we can say AC must be the whole thing minus 30. Okay, I'm right here. Question 9.1.1. We're looking for AC. So we can say that AC is just T, the whole thing minus 30. Okay, so it's T minus 30, that's AC. Yeah. Now, that was question 9.1.1. Now, the following question is 9.1.2. It is said that, excuse me, p squared in its simplest form in terms of t, okay? To express like, now here 9.1.2. So we're looking for p squared in terms of t, okay? In terms of t. Okay, P is over here the basis of the triangle formed by ACB. Okay, we have like this triangle here. It's a right angle triangle. Let me just show it. It's this triangle here. Now, it is a right angle triangle. Now, if I need to work out P will be this is like the adjacent side, okay? We can use Pythagoras. You know, it's gonna be like the longer side equal to the sum of the square of each side. So it's like by using Pythagoras, I wanna say that 30. So it'll be like 30 squared equal to AC squared plus p squared. Okay, that's Pythagoras. Now, see, Pythagoras theorem. Then I can work out p squared. It will be 30 squared minus AC squared. Okay, and then p squared will be equal to 30. 30 squared is 900. So that makes 900 minus AC. AC was calculated earlier is T minus 30. So it's going to be like open bracket, T minus 30, close bracket. And then this will be like 900 minus T minus 30. Again, over here, we shouldn't say T squared minus 900. No, we must times it like this. And then we do T times T, and then T times negative 30, and negative 30 times T, negative 30 times 30. And this will be equal to 900 minus T squared minus 30T, and then minus another 30T, and then plus 900. we need to be careful here. It must be within the brackets, okay? And then this will be 900 minus, that makes t squared. They are like terms. This and that are like terms. We can write it like negative 60 t, and then plus 900. Then excuse me, I can just move this. Okay. This would be like p squared. So I can write like p squared will be equal to 900, okay, minus, I'm minusing what is in the bracket, so the signs of the terms within the brackets will be changed. So that will be 900 minus t squared, okay, plus 60 t, and then minus 900. Now you're like p squared, 900 and negative 900 here will cancel out, and then this makes p squared will be equal to 60t actually. This will be equal to negative okay, let's just say start with it's negative t squared minus 60t, or I can write p squared will be equal to 60t minus t squared. So we can write any of these two. Okay. We have another question. The other question is question 9.3. Okay. No, 9.2. That was 9.1.2, 9.2 now. Let's see. Excuse me. Question 9.2, the question says, show that the volume of the cone can be written as V, okay, V of t, because the function is t, V of t equal to 90p t squared minus a third p, a third pi t cubed. Okay. Let me read over. It says, show that the volume of the cone has excuse me, can be written as Vt equal to 20 pi t squared minus 1 over 3 pi t cubed. Okay. So now let me just show the coin here. The coin is this one. Okay. So maybe. Okay, here's the coin. Now, the radius of the coin here is P. Okay, the radius of the coin here is P. So the volume of the cone is given by, we have this information here. So I'm gonna substitute here, radius is P, so it's gonna be P squared, and then the height of the cone is just T, okay? So let's substitute. We need to prove that the volume of the cone is in terms of T, and then this given by 20 pi t squared minus 1 over 3 pi t cubed. Okay, so initially by the formula of the volume of the coin is like a third pi r squared h. Now, if I need to prove it, I want to say v of t, because the variable here would be t, 1/3 times pi times r. R is r squared, okay? R is p, so r squared will be p squared, as we have it here in the diagram. Let's check it again. R is the same thing as the radius. R is the radius of the cone, okay? So R squared is P squared, and then P squared was calculated in the previous question. We did find that P squared is equal to 60 minus T squared. So I must to write T squared here. Yes, so this will be times 60 minus T squared. Okay, that's R squared, and then times h is the height, which is t. So this can be written as if at times, because all this if at times it's there, I do all these times 60t, and then times also that, this will be a third times 60 is 20, so that makes 20 pi t, okay, minus a third pi times t squared makes a third pi t squared times t there, and then if I times also this t with this and the t with that, and then this will be this will make the volume equal to 20 pi t squared minus a third pi t cubed. This is what we're supposed to demonstrate. Okay, this is exactly what we were supposed to demonstrate here. Thank you. And now the following question is question 9.3. This question here, 9.3, the question says that calculate the value of t for which the volume of the cone will be a maximum. So excuse me, that value of t will be, to get the maximum volume here, it's when we set the derivative of the function equal to 0, okay? I want to differentiate the function now. 9.3, we did prove that the volume of the function, the volume of the cone is given by 20 pi t squared minus a third 1/3 pi t to the power of 3, okay? So now let's differentiate this function. So v prime of t will be equal to what? Okay, the derivative we can do that with respect following this formula. Okay, if you have like a x to the power of n, derivative, this is n times a times x to the power of n minus 1, and now this will be equal to remember the variable here is t, because we write it like that. The derivative will be like 2, because here a is 20 pi is just a number, okay, and then the exponent n is 2, so it's going to be 2 times 20 pi t to the power of 2 minus 1 minus n, which is 3, a third, okay, a third pi t to the power of 3 minus 1, and then this, the volume will be equal to 40 pi t, 2 minus 1 is just that, minus, we can simplify this and that, and then this will be like a negative pi t to the power of 2, okay? And then this must be set equal to 0, because v prime is 0. This must be set equal to 0, and then we will have like 0 equal to 40 pi t minus pi t squared there. Now I can just move the pi t squared to the left hand side. That's going to be or let me just take let's just factorize. Okay, because we have like, excuse me, we have like pi t there and then pi t there. We can factorize. We can take like pi t as a common factor, and then in the brackets we'll be left with 40 minus, so it's like 40 minus minus t. Okay. Oh, okay, maybe I shouldn't do that yet. This is what I can do. I can say, because I have like pi over here, I can take pi as, get rid of the pi, okay? Divide everything, each term here by pi. I divide here by pi, and by pi also. Then this will be equal to okay, what I did earlier was, okay, let's just do this way. I can just take pi t as a common factor, right? Let's do it. This will be equal to, I'm gonna take pi t as a common factor, and then in the brackets here, I'm left with 40, 40, and then minus t, okay, equal to 0. So if this is equal to 0, this implies that pi t is equal to 0, or 40 minus t equal to 0. If pi t equal to 0 implies that t equal to 0, because pi is a constant, it cannot be 0. T must be 0, or if I move the t over, we have like 40 equal to t. So it can be maximum if t is 0 or if t is equal to 40. But t equal to 0 is not applicable, because the length cannot be, the height of the cone cannot be equal to 0. So the correct answer, the unique correct answer here is when t equal to 40 centimeters. Okay, so that was question 9.3, and then let's see, the following question is 9.4. The last question here is 9.4. The question says that what percentage of the sphere was used, okay, to obtain the cone having a maximum value, a maximum volume. All right, okay, let me move here. All right. Question 9.4. Okay, we're looking for the percentage of the sphere used, okay, in order to obtain the maximum volume. Okay. First of all, we got the maximum volume of the sphere when t equal to 40 centimeters, when the height of the sphere was 40 centimeters, according question 9.3 here, we got t is equal to 40. Now, this is what I want to do. Well, let's first work out the volume then of what's the volume of the cone. I'm gonna call it VC. Let's call it VC. The volume of the cone is given by 1/3 pi r squared h, okay? 1/3 pi r squared h. And then when we simplified the previous question, we got like the volume of the cone here was 20 pi t squared minus 1/3 t to the power of 3 here. We're going to substitute the value of t by 40 here to get the maximum volume, okay? Now let's do it. So we had like 20 pi. Okay, it was we got like 20 pi t squared minus 1/3 pi t to the power of 3. Now we're gonna sub in 40, okay, for t, v of 40, because that was v of t, vc of t, excuse me. That was the volume of the cone of t. So when t is equal to 40, in order to get the maximum volume, we sub there wherever we see t by 40, okay? I'll sub 40 here, and then sub 40 there. Now let's see. That's gonna be like 20, okay? If I need to type pi, you press shift, okay, and then this button here, it tells us what pi is, and then open bracket there, 40 close bracket to the power of 2 minus 1/3, and then pi again, we press shift, and then we press this button here, and then open bracket 40 close bracket to the power of 3, and then when we hit equal, and then we'll get the maximum volume, okay? Press ST, it's this number 33,510. So VC at 40, the maximum volume is equal to 33,510 point how much again? 32, I can stop here, 32 centimeter cubed. That's the volume of the cone. Now I need to work out also the volume of the sphere, okay? So let's work out the volume of the sphere. The volume of the sphere. The volume of the sphere, we know that the volume of the sphere is like 4/3 pi r cubed, okay? So okay, so why am I saying no? It's not really in terms of t. Just 4/3 pi r cubed. Now, because r for the sphere is given, okay? I remember it was 30. Let's double check. The radius for the sphere is, yes, it is also said here with a radius of 30 centimeters, and then C is 30 centimeters here. So it was 30 there, and then we can work out this. Vs will be equal to 4/3 pi, and then power of 3 there. We sub in the radius, and then we can still use a calculator. So you can say 4/3, okay, pi, so shift that pattern, and then open bracket 30 close bracket to the power of 3, and then when we hit equal, and then we get, this is equivalent to this is equal to what? We press SD here. This is equal to 113097, 113097.36. So centimeter cubed. Now, because we're looking for the percentage of the sphere that was used to make up the maximum volume of the cone, we will just take the volume of the sphere divided by the volume of everything, okay? So this would be So this will be like this will be like the volume is just going to be like 33,510.32, okay, over 11 3097.36. Okay, let's just do these calculations now. I want to do it like 133,510.32, okay, divided by 11 3097.36, okay, equal to that makes what 0.0.29 6 blah blah blah. So we're going to times this by 100, okay, by 100% to get there. So that makes 29.63% approximately. So therefore it was 29.63% of the sphere, of the volume of the sphere. To make a maximum, to make the maximum volume of the cone. Thank you.